Well, cloud computing has some very interesting impacts on the technical attributes of data centers. There's four key areas where we feel cloud is changing the data center design of today. One is the IT equipment itself used in cloud designs tends to be more uniform, and particularly uniform in its power density. And because of that, it allows us some flexibilities in designing the data center and opportunities to optimize better around a single density rather than around a variable density, which gives us the ability, perhaps, for example, to increase the efficiency of the data center. Another attribute that comes along with cloud is generally a significant higher density. Because of the uniformity of the IT equipment and the absence of a lot of other ancillary type IT equipment devices or blank space in cabinets, we typically end up with higher densities. And generally 8 kilowatts a cabinet is about the minimum kind of density we will see in a cloud environment, but it could be up to 25 or 30 kilowatts per cabinet in a cloud environment. The other thing we see that's important in the cloud environment is larger units of IT deployment and IT changes. And what I mean by that is the number of servers or devices that are changed out in a single instance. You know, typically, historically, we had many customers who might change out 10 or 30 servers at a time. But in a cloud environment, it's common in a large provider to change out servers even at 1,000 at a time. And for smaller environments, you might see changes of 100 servers at a time. And finally, IT system redundancies in a cloud environment can substitute for physical infrastructure redundancies. In order to achieve availability of the entire system, a cloud environment can often be designed to have a better way of responding to the failure of an individual device, such as a server within the cloud environment, or even the failure of an entire facility, allowing it to fail over to another facility on the fly. And because of these redundancies that are inherent to the cloud architecture, we often find that users are willing to consider scaling back on some of the redundancies or availability features that are implemented in the physical infrastructure, such as redundant paths or bypasses or duplicate systems. Well, the impact that cloud has on the way we deal with redundancy gives us a tremendous opportunity to save considerable cost in the design of the physical infrastructure of a data center. And so we can drill in and understand in more detail how, a specific example of how this might work. Consider the servers that we typically deploy, which today have 2 power cords. The IT device, or server, or whatever it is, are supposed to be able to operate without interruption from either cord, even if one fails. However, in most data centers, we don't trust the second cord to work and provide redundancy. And as a result, a lot of physical infrastructure is deployed to ensure that both cords always receive power for all IT devices. And one of the things this drives is the need to put in dual path UPSs, static switches, cross connects, and many devices in our data center infrastructure systems that contribute to the complexity of those systems and also to their cost. In fact, they can add $1 to $3 per watt to the cost of a data center, which could be on the order of, 10 to 20, 30% of the entire cost of the physical infrastructure of the data center. Now, if we have a uniform IT infrastructure, and in that infrastructure we have improved knowledge of the status of the IT device power supplies, we can take advantage of the second power cord on the IT equipment as part of our redundancy design and use less expensive and simpler power distribution systems, such as, for example, what we have historically called Tier 3 type power architectures, which when combined correctly with a server where we understand its performance can give us Tier 4 performance with a Tier 3 physical infrastructure investment. Well, I think anybody who's designing a data center today is either designing specifically with a cloud environment in mind, or they should have an expectation that a growing fraction of their total installation will be of a cloud type architecture. And we see a number of key approaches that ought to be considered when designing a data center to be cloud compatible. One is, we really think it should be designed based around a pod style architecture where we don't think about the rack as the unit of or cabinet as the unit of deployment, but think about a set of cabinets in a zone as the unit of deployment. So when we think about changes or adds, we think about changing that whole group as a set. Which is going to be a lot easier when, say, downstream, we're ripping out and replacing part of our cloud architecture. We don't want the physical devices in a cloud architecture spread around and stuck into empty locations in data center. We want them to be together as a set. So we really want to think very strongly about enforcing a pod-style architecture within the data center. The other thing that's important is to think about density. And when we think about density, we need to think about both the averages and the peak densities that we deploy in the data centers. And when we think about the average density, we need to consider at least around an 8 kilowatt average type number for any new data center, even if it has a hybrid of other kinds of devices in it today, so that it has the potential to scale up into a cloud environment. And of course, that could go further. And as far as the peak rating of the density, it ought to be at least at the 15 type kilowatt level. But you could easily imagine us designing today a data center designed more for 12 or 14 kilowatts average and 30 kilowatt peaks. But that wouldn't be common and probably not recommended at this stage for a data center being built today. So that upping the density from what your historic trends were, particularly the peak power density capability within the data center, is going to be important for new data centers. And finally, we should think about designing the data center in terms of zones, and the architecture should support a zone-type deployment that allows us to have the physical systems have different availability requirements in different zones. For example, today, if I build a data center, I pretty much have built it to one tier level across the entire facility. But if I build it in a modular zone fashion, it's possible to consider a data center where in the future a new zone might be deployed at a different availability level than a previous zone. For example, I could have a tier 4 type data center, and going forward in a cloud environment, I may feel I could deploy at a lower availability or tier level, such as tier 3, and I would like the option to do that rather than using a more costly infrastructure to support a ongoing requirement that does not have that level of availability need.